Hi Sonia. Sorry to take so long to get back to you. I was working on this last night and wasn't quite sure of a solution for you. So working on it a little bit this morning, and here's what I've come up with so far. When you are finding the area between two curves, let's say that we have the area. Okay, let's say that we have a curve, a parabola, y equals negative x squared plus 1. And we want to find the area bounded between that curve and let's say our other curve is y equals x squared. Okay, so we want to find the area bounded between them. So we would find the point of intersection where those where those two intersect, and we would integrate from those two values where they intersect, and we would start with the top curve, which is this one, and we would minus the bottom curve and then find the integral. So that really is like, here's one curve, right? And then here's the second curve in the x squared. So you're really taking, one curve minus the other. But when you look at the next step for your integral, what we would do now is simplify this like that. So now your integral doesn't really know whether you're asking it for, the area between two curves, or if you're asking it for the area between like one curve and the x-axis, right? So that's my line of thinking for question 2, is that we already know the equation from part 1 of our parabola, which is negative 7.5 x squared plus 7.5. And so we know that we want to take another parabola that intersects with it, and we want the area between them to be 5. That's what the question's asking. But when we subtract the equation of that other parabola, when we do our integral, then we're going to end up in the same situation as the line above here, where you're just subtracting the equation of another parabola before you integrate. And that essentially is going to give you the equation like this, that the integral doesn't know whether it's one or two curves, basically, right? But we do know that we want this equal to 5. And so if we ask it for the definite integral between minus 1 and 1 that has an area of 5, and we solve this equation for A and K, because we also have the points 0, 1 and 1, 0, or negative 1, 0, sorry. If we do that, then I think we're going to get the A and the K, and I haven't honestly had time to work it out, but you could use like a program like Symbolab. If you go to www.symbolab.com, and it will compute the integrals for you, so it'll save you time, just instead of going through all that work, just making sure that you're going to get the area that you're looking for. But if you do this and you set it equal to 5, then I think you'll end up in the same place where you were in question 1, where you ended up with an equation of A in terms of K, and then if you sub in the point A and K, if you sub in the point 1, 0 or negative 1, 0, then you'll be able to solve A for K and put it back in and figure out the equation of the other parabola that we're looking for. So I think that approach should work for you. If you want to give it a try, and like I said, you'll save a lot of work and time if you use the Symbol Lab. And I do know also that in seminars that your professor does give a lot of big hints and sort of works through these problems with you. So you might want to check and see if that's the approach that he's using to this question also. Okay, so I hope that helps.